What's up, guys? Welcome back to Fantastic Chemistry Podcast. My name is Pete. I am your host, and another host is Ch6, somewhere around here. You will see him. He will pop up sometimes. How you guys doing? Just checking in. I know there's a lot to learn. You can kind of get a feeling now how difficult this class could be. Right? There's just a lot of things to learn, a lot of new skills to prepare, to practice, right? What have we learned so far? You have pKa that you have to memorize, acid-base reaction, drawing bond line structure, you have to be familiar with it. What else? Enantiomer, stereoisomer, chirality, and percent enantiomeric excess, really hard to say. I just throw keywords at you, but you probably have it somewhere in your head, right? Again, one thing that you should do, again, I can't stress enough about making the second note, right? That will keep you on track. Put anything in your head that feel like different knowledge, right? You link them together and everything gonna line up perfectly, right? This course is built on each other, so which means that chapter 1, chapter 2 is built on from chapter 1, chapter 3 is built from chapter 2, chapter 4 is required knowledge from chapter 3, and build on to that. If something's missing along the way, let's say you're not good at chapter 4, chapter 5 might be difficult to follow. Okay, second note will help you so much more. So I highly recommend, if you haven't done it or you've done it, just like kind of do it, please do it. All right. The practice, the study guide, it helps a lot. Right. I even have the what's it called? An old exam, which is it's not like our format, but at least you get to see like what type of question that you're gonna see on the quizzes. Okay, and even the final as well. Okay. All right. Try to keep up with me. All right. This chapter 6, you're gonna feel kind of a little bit lighter. Right? Chapter 6 is short, right? And half of the chapter 6 you have learned it in Gen Chem 2, I think 2. Okay. All right, let's take a look at right here. So electrostatic interactions. Let's say if I have two objects hanging with a rod or whatever, metal rod, and I run an electrical current through them. Right? So one is negative, one is positive. When these two objects gets closer, what's going to happen to it? You can guess that the negative and positive, they attracts, right? They attract one another. If now change the scenario, so change the positive charge to the negative charge, right? And when these two objects get more closely, they will, what happens? They will repel. Okay, so my point is negative and positive, they attract. And this is how we draw it, right? How we show that negatively charged species and a positively charged species, they attract. So start with a positive charge. So you see positively charged species for example, in ionic bond, one of them going to have full charge, or in a polar covalent bond, you're going to see the partial charge. Right? Same thing with the negative. You will see either full charge in ionic bond as well, and in polar covalent bond, you're going to see partial charge. Right? And we're going to use the arrow, the curve arrow we've been doing since chapter 1. Show that negative and positive they attract by drawing an electron transfer. Okay, so we use curve arrow to show electron pair distribution from negative to positive. All right, and the negatively charged species is called a nucleophile, and a positively charged species is called an electrophile. That's how we communicate. All right, nucleophile mean love. Nucleo come from nucleus. This species love nucleus. What's a nucleus? The positive charge. That's a nucleus. That's why it goes to the nucleus, attract nucleus. All right? And you can guess that electrophile love electron. This guy loved electron. That's why I write electrons. We draw from electron to the positively charged center. Okay. All right. This is the basic concept of drawing mechanism. Let's talk about how do you identify who's a nucleophile and who's the electrophile. If you know who's a nucleophile, who's the electrophile, that's all you have to do. Nucleophile, attack electrophile. That's all you have to do. Okay. Let's take a look at the next video.